Assalamu alaikum warahmatullahi wabarakatuh. We're going to solve today questions on work energy theorem. Before we solve the questions, just we're going to revise a little bit what do I mean by work energy theorem. We studied before work equals force times distance cosine the angle theta. And we have three cases. Work could be positive, could be negative, could be zero. We have positive work if force is parallel to the displacement, like you have an object and you applied force on this object, so the object will move distance d. So force and displacement are in the same direction. In this case, I will have a positive and the angle theta will be 0. Cosine 0 will equal 1. Work will be negative if you have a friction force. So the same question, but the friction is opposite to the direction of motion. Here is the direction of acceleration of motion, and I have a friction. The object will move a distance d. So in this case, still F and D are parallel, but they are in the opposite direction. The angle between them is 180 degrees, and we know cosine 180, it's -1. And work is 0 if the angle between the force and displacement is 90 degrees. Like, for example, you're holding a bag in your hand and you're moving. So here we have applied force up and the direction of motion, the displacement in the direction. In this case, the applied force and the displacement are in the opposite direction. Now, work equals change also in the kinetic energy. So if you apply work, if you apply a force on an object and you displace this object from one position to another, work will equal change in kinetic energy of that object. Change in the kinetic energy means the kinetic energy final minus initial. Kinetic energy, it's half m v final square minus half m v initial square. This is work energy here. Now we'll start solving the first question. The first question, we have a toy car with a mass of 2 kilograms. Starts at rest. A spring performs 196 joules of work on the car. What is the toy's car final velocity? So here I have the mass m is 2 kilograms. Start at rest, that means the initial velocity is 0 meters per second. The spring performs 190 joules of work. So I have W 196 joules. What is the toy's final velocity? I need the final velocity of the toy. So here you have a car, and the car at the beginning it's as at rest. Here we have a spring, and the spring will push this car. So here we have force applied by the spring on the car, and that caused the car to move, to change. It is kinetic energy. So we're going to use work energy theorem. Work equals change in kinetic energy. When we study the conservation of energy, also we can solve this question with the conservation of energy. So, and this will equal half m v final square minus half m v initial square. Since v initial is 0, so this term will equal 0. The value of W is 196 equals half. M is 2 times V final square. 2 and 2, we can cancel them out. So if I need V final square equal 196. So if I need V final, I'm going to take the square root for both sides. So V final will equal 14 meters per second. Okay. Now we'll solve more questions to get the idea. Here we have a skateboarder with a mass 30 kilograms. So M is 30 kilogram. Ends up with a final velocity 7 meters per second. So V final 7 meters per second after a push. So there is a force here. So someone pushed this man with work. He gives you the value of this work. He gives you the value of this work, which is 360 joules. What was the skateboarder initial velocity? So I need the initial velocity. So we have, again, change in the velocity, and there is work. So we're going to use work energy theorem, or as I said, conservation of energy, because it's the same. We can solve it with same method. So work W equals change in kinetic energy final, minus kinetic energy initial. Okay, since they have the same mass, so W is 300, is substitute for 360, this equals half, same mass, so I'm going to take M outside and half outside. B final square minus B initial square. I just took M outside as a common factor. So cross multiplication. Okay. 360. Or keep it as it is without cross multiplication. Here, keep it. So 360 equals half. M is 30. B final 7 squared minus the initial square, we don't have it. So this is 15. 15 times 7 squared minus the initial square. We can keep it as it is instead of taking the half M as a common factor would be better. Now I'm going to distribute. Okay. So 15 times 40. Or before distribute, I'm going to divide both sides. It would be better if I divide both sides by 15. So I'm going to divide both sides by 15 to get rid of 15. I'm going to divide by 15, divide by 15. Okay? So it will be 360 divided by 15. This will give us 24. 24 equals 7 squared is 49 minus the initial square. Take this to the other side. Okay, so minus the initial square equals 24 minus 49. I need to get rid of the square. I'm going to multiply both sides by -1. So the initial square will equal 49 minus 24. And then take a square root for both sides to find the initial. So the initial will equal 5 meters per second. 5 meters per second. Okay. Now we'll take also another example. Let's see this one. Here we have a student wearing a frictionless inline skates on a horizontal surface, is pushed by a friend. So a friend push this student with a velocity, with a constant force. The value of this F is 45 Newton. How far must the student be pushed? So I need the displacement, delta X. Starting from rest, so we have the initial equals 0 meters per second. So that here final kinetic energy, So the value of the kinetic energy final equals 352 Joule. 352 Joule. Again, we have applied force, and this force causes the object to change its velocity, to change its kinetic energy. So it's force energy theorem. Always we write the given, check the units. The units are consistent: meter per second, joule, Newton, all of them SI units. I don't need to convert. So now we're going to just write the formula and substitute. So work equals kinetic energy final minus kinetic energy initial. Now, since we have initial velocity 0, so kinetic energy initial is 0. How can I find work? Work is force times displacement, and both of them in the same direction. So it will be positive work. And this will equal the value of the kinetic energy final, which is 352 Joule. This will be equal 45 times the displacement. The displacement, I need to find it out. So I need to find D or delta X. D or delta X. So divide both sides. Divide both sides by 45. By 45. By 45. So the value of the displacement will equal 352 divided by 45, and this equals 7.8 meter. This is D, the displacement, or delta X, or delta X. Okay, let's solve another one. Let's go to this one. Here we have a 75 kilogram bobsled, as you see in the photo, is pushed along a horizontal surface. So the mass of the sled, M, 75 kilogram, is pushed along a horizontal surface by 2 athletes. After the bobsled is pushed a distance, so we have the distance D for delta X equals 4.5 meter. Starting from rest, that means the initial speed for the sled was 0, it wasn't moving. To speed, so we have B final, 6 meter per second, speed 6 meter per second. Find the magnitude of the net force on the bobsled. So I need the value of the net force. Now, after we run the given, check the units. The units are consistent. Kilogram, meter, meter per second. So the units are fine. I don't need to convert. We go now, just write the formula and substitute. So here I have force and change in velocity. So it's going to be work energy theorem. So work will equal kinetic energy final minus kinetic energy initial. And since you start from 0, so this will equal 0, the kinetic energy initial. How can I find W? W, it's force times distance. This will equal half mv final square. Now the value of F, we don't have it. Distance or displacement is 4.5 equals half m 75, and the final velocity is 6 square. Okay, so we have to calculate this one first. So force times 4.5 equals, let's do this one. We have half times 75 times 6 square. This will equal 1,350. I need F, so I'm going to divide both sides by 4.5. by 4.5 to find F. So divide by 4.5. This will give us 300. This is the value of F. So F will equal 300. Don't forget the unit, newtons. Okay, one more example. We'll see this one. Here we have 2 times 10 to the power 3 kilogram car. 2 times 10 to the power 3 kilogram car. So this is the mass M. 2 times 10 to the power 3 kilogram. Accelerates from rest. So V initial will equal 0 meter per second. Under the action of 2 forces. One is a forward force, so I have 2 forces. So the forward force or the applied force is 1,140 Newton, provided by the traction between the wheels and the road, and there is 950 resistive force. So here I have the resistive force is 950. So I have to find F net. I have F net. Now remember, to the right, the force is positive, left negative. So F net will equal 1,140 minus 950. 1,140 minus 950, and this will equal 190 Newton. This is the net force acting on the object. Now, due to various friction, use the work energy theorem to determine how far the car must travel. So I need the displacement, or delta x, to reach the final velocity 2 meters per second. Okay. Now I have a change in the velocity and I have applied force. So we're going to use work energy theorem. W equals kinetic energy final minus kinetic energy initial. Now again, I don't have velocity here, initial velocity, so this will equal 0. Work will equal F net, the net force acting the object, times the displacement. This will equal half M V final squared. The net force will be 190. 190 times the displacement D equals half. M is 2,000 of 2 times 10 to the power 3. The final speed is 2 squared. Okay. Now let's calculate this one. I have 190 equals V equals 1,000 times 4. It's going to give us 4,000. I need D, so we're going to divide both sides by 190 by 190. So D will give us 21 meters. Okay. Now the last question we're going to solve is this one. Here we have a student slides 0.75 kilogram textbook. So the mass of the textbook is 0.75 kilogram across a table, and it comes to a rest. It comes to a rest, that means the final velocity is 0. Comes to a rest. Now traveling 1.2 meter, this is the distance, it's a unit of distance, so I have D or delta x equals 1.2 meter. given that the coefficient of kinetic friction between the book and the table, so we have a new kinetic equals 0.34. Use work energy theorem to find the book initial speed. We need the initial speed for the book. Okay, now we push the book will stop eventually, and there is a friction force, always the friction, if this is the direction of motion, the friction will be opposite to the direction of motion. So there is work done due to the friction. The work done due to the friction will cause this object, this book to move. Here I have a friction. Okay. So this will equal kinetic energy final minus kinetic energy initial. Now we said the final velocity equals 0. So that means the kinetic energy final is 0. How can I find W? W is the force of the friction times the displacement or a distance, and always the work due to friction is negative. Okay, so this will be negative, equals half m v final square. Now let's substitute minus, okay, the value of the friction force. The friction force is in mu k times Fn. Fn here, Fn, the normal force or reaction force will be equal Fg. How can I find Fg? It's mass times free fall acceleration. So Fk will equal a mu k times Fn, Fn, which is mg times d. This will equal half m v final square. M and m, they can cancel out. Okay, and then substitute. This is also be negative. Negative and negative also they cancel, so it will be mu k, which is 0.34 times 10 times distance d. The distance d is 1.2. This will equal half times, so this is v initial times the v initial square. I'm going to do cross multiplication and then take square root for both sides. So v initial will equal square root of 2 times 0.34 times 10 times 1.2. Okay, so let's do this on the calculator. I have 2 times 0.34 times 10 times 1.2. It's 2 point, so V initial is around 2.8 meter per second. 2.8 meter per second. Okay, I'm gonna stop here. Next video, inshallah, we'll solve questions on gravitational potential energy and elastic potential energy.